Hello guys, this is Vamsi. Now we are discussing about project of deep learning with big data. In this project, we have five parts, and the first part is a data set of images or audio files. In this data set, we have taken LSUN. LSUN means large scale scene understanding. It is a data set that is used to detect and speed up the progress for scene understanding. That includes screen clarification, silence prediction, and room layout emission, etc. It is used for image progression. This dataset by Princeton University consists of around 1 million labeled images for each scene and obsession categories where the test contains 10,000 images. And this is our official website. And in part 2 contains CIFAR 10 dataset. First step, we need to create a GCP and I create a folder and a subfolder too in the VM instance. And I upload all the CIFAR 10 dataset to the virtual machine under the main directory. I run the I command to check if the updated data is present and it was successfully updated. I later upload it to the GP NDB folder. I upload the data using the command cpdata. After checking for the data in the JP folder, it was successfully uploaded. And now again uploaded the data to the CIFAR 10 data subfolder. Yeah. And next in part 3, build, train and test CNN on CIFAR 10 dataset. Setting up a convection layer and performing convection computation dot product. I define a function to set up a convection layer. The parameters begin input inputs. Now we are showing these batch HW channels. And next filter shapes which I used is filled HW in channels. And these are like for example 5, 1. After giving these all inputs, then we can get this code. Setting up a pooling layer and reducing spatial size. I define a function to setting up a ReLU layer and performing computation dot product plus bias. I define a function first to set up a ReLU layer and activation function layer. Then I perform the computation, this code like dot product plus bias. And ReLU in full, it's like called like rectified linear unit. It is a popular activation function used in CNN. In this layer, the bias has already been initialized. In this, we have used the parameters are for input, output for the previous convection layer, dot product input, like we used in part 3. Then setting up a pooling layer and reducing spatial size. I define a function to create a pooling layer, reduce the spatial size of the inputs data. The pooling method used is max pooling, kernel size 2 by 2, and stacks 2, and the parameters are inputs, output of the previous layer, return output of the layer. So then when we create the inputs, then we can get the code creating a pooling layer. Like we give the examples of 1 to 2, then these are the examples. Then we can get the return pooling layer. Like after completing setup pooling layer, now we need to set up fully connected layer and perform in computation. In this, we need to use like inputs, weight plus bias. I define a function to set up a fully connected layer. I also perform computation, product, inputs, weight plus bias so that we can get the results. Like the parameters are inputs, output of the previous layer, and the size of output, number of out channels. So then we can get this code. Like now we have created the connected layer and compute dot product. Like get the number of input channels from the output. Computation of the FC layer dot product input. So we'll get return the results like output. So after that, like we need to creating first convention layer. I create first convention layer with um, prelude layer and performing computation XW plus B. Filter shape should be like 5 into 5 input channels, output channels 32. I create the first convention layer, the extract features and get the results of output, that is dot product of input into weight. I create the ReLU layer for convention layer and accepts the output from first convention as inputs, performing computation and return the outputs of the layer. So first I create first pooling layer and reduce this partial size. Like we used to do that size like 5 into 5. So we can get the code. The like image should be like reshape -1 28 28 1. With that code we can get that convention layer output. Create convention layer and compute dot product. Pooling layer output is equal to create. So that with this code. And next we need to create another convention layer as usual.